Good afternoon. In this lecture, we will discuss sampling distribution. Sampling distribution. In the last lecture, you have seen that population is characterized by probability distribution with certain parameters. Also, we have discussed that sample can be collected from the population and then estimate of population parameters can be found out in terms of x bar, in terms of a square. X bar and a square, each one is known as statistic, okay, and x bar a square collectively you can say statistics. So, population parameter, sample statistic, they are synonymous. When I talk about population, I talk about population parameters, talk about sample, the sample statistic. Statistic is the estimate of parameter. Okay. Now, if I say that x bar is an estimate of population parameter mu, then what is the distribution of x bar? Similarly, you see that a square is the sample variance for the variable x and it is an estimate of sigma square, that is a population parameter. You may be interested to know the distribution of a square. Getting me? The distribution of a statistic is known as sampling distribution. So, when we talk about sampling distribution, we talk about the distribution of a statistic computed from the sample, that distribution of that. Now, here x bar is a sample statistic. What is the distribution of x bar? Similarly, a square is a sample statistic. What is the distribution of a square? Under sampling distribution, we will discuss these two, but please keep in mind, in general, if we say that theta is equal to, let it be theta 1, theta 2, like suppose theta k, there are k parameters for theta, then definitely suppose your phi is the sample statistic, then corresponding to every population parameter there will be sample statistic will be there. Now, by sampling distribution we say what is the distribution of this statistic, what is the distribution of this statistics, what is the distribution of this statistic. It may be univariate, it may be multivariate. So, if you are interested to know collectively what is the distribution of this statistic vector k cross 1 vector, then it will be multivariate distribution, probability distribution. Essentially, by sampling distribution you are talking about probability distribution only, but the difference is you are talking about the distribution of not the variable characterizing the population, rather the statistic computed from the sample, distribution of that statistic. Clear it is. For example, we have taken the, if we consider the same example again, the profit. If you see the 12 months data, 1 to 12. So, your profit is there, different values of profit. So, you will calculate mean profit average per month. My question here is, what is the distribution of x bar? Okay. So, with this line, today's discussion is sampling distributions, and you see that there are unit normal distribution, Z stands for unit normal distribution, then chi-square distribution, T distribution, F distribution. These are the most popular, mostly used, widely used distribution for sample statistics. Then we will discuss central limit theorem, finally sampling strategy, because how do you collect the data, it all depends on what strategy you will be adopting, because the data collection process if wrong or faulty, analysis will not give you good result. Okay. So, you may be wondering that where from this, suppose you have collected one sample, for example, you collected the height of people for a particular community, suppose n data points you have collected 1 2 dot 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 n, your value x value is x1 x2 dot 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 xn. You are thinking that I have computed x bar here and a square here, and these are all because once you collect data, these are the fixed values. So, your x bar is also a fixed value, a square is also a fixed value for a particular sample. Then where from this distribution is coming? The distribution concept is coming because if you do the same sampling next time, there is no guarantee that you will get the same value of x bar, same value of a square. That is why in statistics, all statistics are, or other way each statistic is a random variable, statistic is a random variable. In this figure, you see this figure that sample n samples, sample 1 to sample n collected from a particular population, and the sample size is n for all the cases. Sample size means the number of observation collected per sample, and if you compute the mean and variance from each sample, you will be getting for first sample it is x1 bar and s1 square, x2 bar, s2 square for second sample, like this, and it is obvious that all those values will be may not be same, will be actually it will be different. Suppose if I say that sample 1, sample 2 like sample n, then if you calculate your mean and calculate variance, x1 bar is the first sample mean, x2 bar is the second sample mean, like this xn bar is the nth sample mean, s1 square is the first sample standard variance, and s2 square is the second sample variance, like this the variance sn square. Now, as these are not same value, what will happen? If you can draw a histogram, how? You can find out the smallest value of x bar, let it be, if I say x within bracket 1 bar. Originally what happened? Originally you have x1 bar, x2 bar, like this xn bar. If I say this is a vector x bar, which is this one, this T stands for transpose, then you are ordering them from smallest to largest, then the same thing what will happen if I say that some order we are giving then this will be x 1 bar, x 2 bar, x n bar. So, this is the smallest one is this and the largest one is x n bar. So, if you plot, you will get, you will develop a histogram, you may find out a distribution. It may be like this. It may be like this. So, that means what we are trying to say, that if you collect sample one after another from the same population of same size for the same variable, you will get different values for that sample statistic, and that sample, that is why the sample statistic is a random variable, and you have a probability density function for the random variable, and that density function is the sampling distribution function. Okay. Now, you have to know that what are the distribution that comes under sampling distribution. I told you earlier that there are 4 most popular sampling distribution like Z distribution, chi-square distribution, T distribution and F distribution, and this concept is very vital concept, I am telling you, and very important for later stages when we talk about any multivariate model. For example, multiple regression, there are several beta coefficient, you will be finding out that regression coefficient. These regression coefficient through data, sample data you will be estimating, they are basically the statistic. So, each parameter will have a distribution. How do I know that what distribution it follows? If you do not understand this, you will face problem there. So, this is I can say that one of the most fundamental concept, and it should be, you should be thorough about this concept. Okay. And now, let us concentrate on what is Z distribution. I am sure that you will not face it a difficult one, because all of you know that this left hand side the figure, if you see, this is the normal distribution, and the probability density function is f x equal to 1 by, I am writing here once more, f x equal to 1 by root over 2 pi sigma square e to the power minus half x minus mu by sigma square, and x varies from minus infinite to plus infinite. Okay. Now, where x is a random variable, this is the original one, original random variable, original one what you have observed, correct. Now, let us transform x in this manner. Let z is a transform variable of x, which is x minus mu by sigma. So, you have observed x, you are creating another variable z, which using x as well as the population parameter like mu and sigma, then this is what is known as the transfer standardized variable. This is known as standardized variable. So, when a variable is subtracted by its mean and divided, and the resultant quantity is divided by the standard deviation, that is known as standardized variable. So, that means by standardized variable we mean that the variable minus its expected value, that is the mean, divided by that what I can say sigma means basically x minus mu, expected value of this square. Square root you give, this square root of this. because we are considering standard deviation, square root of this, correct. Now, what will be the mean value of z? 0. How?
Since mean is subtracted.
Every case, basically you can write in this manner. Suppose what is mean? Mean is, suppose if I write mean is expected value of variable z. Here we are talking about mean j mu z. So, that means expected value of x minus mu by sigma, that means 1 by sigma expected value of x minus expected value of mu, and c expected value of constant is constant. So, expected value of x is mu minus mu, it equal to 0. So, that is why the z is a random variable whose mean value is 0. What will happen to its standard deviation? You will get 1. In the same fashion, you can find out that what is the standard deviation. Standard deviation means expected value, that is the variance you find out first, variance of z, which is expected value of your z minus expected value of z, that whole square. So, expected value of z already you got 0. So, this basically expected value of z square. So, it is expected value of z is nothing but x minus mu by sigma square. So, if the variance of x, suppose variance of x is sigma square, the variance of a x where a is constant, it will be a square sigma square. So, it will be sigma square. So, that means you can write this 1 by sigma square into expected value of x minus mu square. What is this? Expected value of x minus mu square, that is the sigma square. So, your sigma square by sigma square, this is 1. If this is the case, now you see that in this equation, come back to the slide again, what we have put? We put z equal to x minus mu by sigma square, our resultant equation, that probability density function for z, which is 1 by root over 2 pi sigma square is 1. So, it is 2 pi into 1 means 2 pi square root e to the power 1 by 2 z square. So, this is the conversion of any variable, for example, this normal variable to its unit normal distribution. So, z distribution is also known as unit normal distribution, because its mean value is 0 and standard deviation is 1. Okay. What is the use of why should we convert to unit normal distribution? The reason is even if there are many variables, but once you standardize those any variable, it will be an unit normal. So, you require only one unit normal distribution table, and using that you are able to what I can say, use that table to different situation, even though the original variable mean and standard deviation differs. Okay. So, this is our example, and if I consider profit, we are considering the profit, I am showing you that what is the use of standard normal distribution. Here assume the variable profit per month is normally distributed with mean of rupees 11 millions and standard deviation of rupees 1.5 millions. What is the probability that the profit per month will be within 12.5 millions? How do you go about it? You see the left hand side this figure, it is in the original variable, right hand side is the unit normal one. Now, if you see this x axis, the bottom one, you see what is the mean is the middle value, and everywhere that 1 standard deviation, 2 standard, 3 standard deviation, both side the demarcation is there. Now, as sigma equal to 1, that same will be now mean will be 0 and 1 into 1, that will be 1, that is minus 1, minus 2, minus 3, like this. So, this line is what is the z line, because you are interested to know that your probability of profit less than equal to 12.5 rupees million, and if I convert into z value, it is coming 1. So, probability z less than equal to 1, that means this one, this is the z equal to 1, the left hand side values. Probability z less than equal to 1 will be the area under the normal distribution curve from minus infinity to that z value, because we are talking about within this. Now, you have standard normal table. Now, what you will do, once you get the z value, you go for the table. So, our z value is 1, and you see that this shaded portion is the probability, this area is the probability, and whose value is 0.8413. So, you are able to find out the probability that your profit will be within this. Now, second sampling distribution is chi-square. Okay. Do you have any idea that when you will use chi-square distribution? You find out that if you go through the standard book, like very good book, Johnson and Wichen book, you will find that everywhere, maybe when you talk about the constant density contours, there or statistical distance, the chi-square distribution is used. But why chi-square distribution is used instead of t distribution, or instead of z distribution, or instead of f distribution, or any other distribution? What is the basis? That means, we must know that what is chi-square distribution, how it is generated, and where it will be used. Now, you see this slide here, what we are saying, that if z1, z2, zk, what is z? Z is normal distribution, unit normal. So, you have collected suppose k observations, and those k unit that normal observations are that z1, z2, zk, and you are creating one variable which is the sum of the normal variable, unit normal variable square. What I mean to say here, then suppose you have collected in k data points 1, 2, 3 like k, and you have x values for x1, x2, x3, let it be xk, and you know z values, z equal to x minus mu by sigma, assuming that mu and sigma are population parameter, then you are getting z1, z2, z3 like zk. Now, you are making z square, z1 square, z2 square, z3 square, like this zk square. Now, if you take a sum of this zi I equal to 1 to k, you get a quantity. This is also a statistics, because this is the linear sum of the square of the values of the normal unit normal variable. Then this quantity, that y, what you have created here y, I have shown here, it is here y, and anyhow you can change it to y, no problem. Okay. So, this quantity follows chi-square distribution with how many degrees of freedom? K degrees of freedom. So, what is the essential learning here? Our learning is, suppose I know that there is a normal variable x, you have collected data on it, you converted it to standard normal, each of the observations is squared and you have taken a sum, and that sum you used for different purposes. That sum will follow certain distribution, that distribution is chi-square distribution. Okay. Remember this one. Suppose usually why normal distribution will start with normal distribution, because normal distribution plenty of things in the real world, most of the things can be converted to normally distributed, that behavior, most of the cases. So, that is the starting point. Now, for the purpose of your analysis, purpose your model building, for the purpose for which you want to use it, there what is required? You require the sum of the square of the variables values. Then what you will do? When you collect one sample, you have to have the distribution of that value, that is chi-square distribution. Any question? Understood fully or not? Sweetie, any question? Okay. And the general form of chi-square distribution is like this, that f y is 1 by 2 to the power gamma k by 2, gamma k by 2, and this is the case, and the mean value of chi-square is the k, which is degrees of freedom, and variance is 2 times degrees of freedom. And this figure you see that this is the probability density function for a chi-square variable. Now, that if x is chi-square, then what is happening here, 1 to 8, these are the values, and ultimately you will be getting different shape of chi-square density function. When your k equal to 1, this is this as well as k equal to 2, it looks like exponential distribution, but slowly that shape will change. So, degrees of freedom plays an important role in chi-square distribution. In Z distribution, what is the degree of freedom required? No degrees of freedom. We have not discussed anything related to degrees of freedom in Z distribution. When the unit normal distribution you table you see, there is no degrees of freedom column. So, that means in Z distribution it is basically not affected by the degrees of freedom available with the data set. Chi-square distribution, when you talk about chi-square distribution, please keep in mind degrees of freedom is coming into consideration, and chi-square is nothing but the normal square. My x is normally distributed, I am making the square, linear sum of the square of x, that is my chi-square distribution. So, you may be wondering that where is the use? Now, see, I told you we want to find out the distribution of sample statistic. Getting me? Now, one of the sample statistic is a square variance, yes or no? Very much. What is the distribution of a square? How do we know? What will be the distribution of x bar? See, x bar is 1 by n sum total of xi. X is normally distributed variable. So, x bar, if x is normally distributed, x bar also follow normal distribution. We will create Z by considering x bar minus expected value of x bar by variance of x bar, then unit normal distribution. I will not tell anything related to this computation, later on I will tell you what is this. From central limit theorem you will know what will be the this distribution, but irrespective of what I mean to say here, that irrespective of the value, that x bar value, if you collect data from a normal distribution, then x bar will be normally distributed. Getting me? Now, what will be the a square? What is a square? A square is 1 by n minus 1 sum total of I equal to 1 to n xi minus minus x bar square. Can you find out any similarity here? What you have done? I say x is normally distributed, x bar is also normally distributed, difference is also normally distributed. Then you have made the squaring this. So, when normal variable is squared and you take summation and do little bit of manipulation using the population variance, what you will get? You will get standard normal z and summation of square of standard normal z. Is it not correct? You see this this one slide, what we have shown here, a square is just, it is nothing but the formula we have given, x1 minus x bar square like this, plus x2 minus x bar square plus xn minus x bar square, and sigma square is divided. This sigma is the population variance. Now, this quantity is coming like z1 square plus z2 square plus zn square. So, it is the sum total of normal square, the variable value square. So, it is chi-square distribution. That is why when we will go for interval estimation of variance, we will use chi-square distribution, because it should come to your mind that why x bar, for x bar we are using normal distribution, but for s square we are using chi-square distribution. That means, the crux of the matter is here. This is the development, this is the development, fantastic. Then you may be wondering that why the n minus 1, already we have seen that while calculating the s square 1 degree is lost, then same thing continues, and ultimately our this n minus 1 a square by sigma square, this quantity follows chi-square distribution with n minus 1 degrees of freedom. Okay. Any question for this? So, any question? No question? I think it is obvious now. So, keep in mind this one, because many times you will be using this type of derived units. You will add square and then add, and chi-square is required, but you do not know what distribution you will be using. Just follow this concept and you for yes chi-square. Some other case it will be other distribution. Okay, this is the use. For example, if we consider the data, then profit variance obtained through the 12-month data, assuming population variance is, you can find out the distribution of the variance component computed from the 12 months data. It is all the uses of this chi-square distribution will be revealed in subsequent lectures, but the concept remain same. When we will use chi-square distribution, this is the concept. Okay. Chi-square table, when you have gone for Z table, please keep in mind that in Z table there is no degrees of freedom column. Chi-square means there will be degrees of freedom. So, the first column itself is degrees of freedom 1 to 15, it will be up to infinite, because chi-square value can go up to that level. Then there are different probability values here, and for different probability values what will be the your chi-square value. So, how to use this table? Any idea? For example, let the chi-square distribution PDF is like this, chi-square, this is function of that chi-square mean PDF, let the distribution look like this. Okay. Now, I want to know what is the chi-square value for the probability of this side, let it be alpha, which is 0. Let it be 0.5. From this table Can you find out this value, chi-square value? What will be this chi-square? 0.05. Understand, because these things you will be requiring later on. You have to see this chi-square table frequently. What I mean to say, I know the probability, right hand side probability here, for which I want to know what will be the chi-square value. If you are giving like this chi-square with probability 0.05, you cannot calculate. You cannot find out the value from here. Which degrees of freedom? Is it 1 degree of freedom or 15 degree of freedom or 120 degrees of freedom? So, that means another quantity should be here, which is known as degree of freedom. So, suppose k equal to 1, then what is this value? K equal to 1, probability is 0.05. So, your chi-square value is 3.841. So, my this value is 3.841. Suppose you require a value where the probability, so what is this? This one is probability that chi-square value is this probability that chi-square value, this value that will be greater than some value. Getting me? So, let any value we are basically k equal to 1, some value, this is 3.8, but that value we will say that chi-square computed value. Getting me? Probability that this is my chi-square is when chi-square is computed this value, this will be greater than this is the value, this side, less than this will be other side. Now, if your degree of freedom is 6 and you want the probability that the value is that 9.995, then your value chi-square value will be 0.676, which will be somewhere here. So, you are talking about the total probability this side. Okay. Now, let us see t distribution. T distribution, when will you use T distribution? First, we have to understand when we will be using T distribution, then we will see the uses of T distribution, then again I will show you the table, how to use table to find out the different critical values for T distribution. You see here, if z and xk are independent, normal and chi-square variable. So, we are now considering two variables. One is normal variable, that is unit normal, that is z. Another one we are talking about chi-square, let it be chi-square with k degrees of freedom. Fine. Now, you create another variable which is t, which is z by square root of chi-square k divided by k. Now, in your development process, suppose when you are developing model, if you find that you have created some variable which is of this form, that normal by square root of chi-square divided by its degrees of freedom, then this quantity, the t, will follow T distribution with k degrees of freedom. T distribution with k degrees of freedom. So, that means T distribution case also degree of freedom will come. Degrees of freedom is very important for chi-square distribution, for T distribution also. And you see it is the shape of T distribution, it is similar to normal distribution. When your this side, the degree of freedom will be infinite, that will exactly match with normal distribution. What is the mean value of t distribution? You are not getting. See z, what is the mean value of z? 0 mean. So, that mean value divided by something 0 is coming. So, what is happening here? The t distribution mean value is 0 and standard deviation value is square root of k by k minus 2 and k must be greater than equal to 2. And you see that this one here, in the diagram itself, the mean value is 0. What it is? What is its use?
Actually, it takes both mean and standard deviation into account.
Which one? It's there, no? Basically, it takes what is the parameter of t distribution? What is the parameter of normal distribution? Mu and sigma square or sigma. What is the parameter of t distribution? That is the case. What is there here? See, everywhere k is there. You see the function gamma k plus 1 by 2 k, here k, everywhere k is there. So, that means the parameter of this distribution t distribution is the k, degrees of freedom, and you are getting, that is why mean is 0 and sigma square in terms of k. Getting me? So, you will know the parameter from the PDF only. In t distribution PDF, all other values are constant. T definitely the random variable, otherwise for other things you see that pi is a constant one and that is that pi, otherwise only k is there everywhere, gamma distribution is given. Getting me? Now come back to this use. What is the use of, when do you use t distribution? Now let us see that the t is like this, that x bar minus mu by s by square root of n. You have created this type of composition. How it will, why it will come, or why how it will come? I am showing you one thing, that when we talk about the distribution of x bar, so x bar is 1 by n sum total of xi. Then I asked you what is the expected value of x bar, you said that expected value of 1 by n sum total of xi. So, that means 1 by n expected value of x1 plus expected value of x2 plus expected value of xn. What is the expected value of x1? All are mu. If x is normally distributed, every observation will be normally distributed with the respective mean. So, it is basically n mu by n, that is mu. So, we say that expected value of sample average is mu. Now, what will be the variance component? If I want to know variance of x bar, that means this is nothing but variance of 1 by n sum total of again xi. So, as I said that variance, if you that 1 by n square, then variance of x1 plus variance of x2 plus variance of xn. x1, x2, xn all are normal random variable with variance sigma square. So, 1 by n square, then sigma square plus sigma square, like plus sigma square, which will be n sigma square by n square, that is sigma square by n. So, that means using that, if I create a x bar, I told you if normal be distributed with mean of this, mean will be mu and x sigma square by n. Now, you are creating a z variable here. If you create a z variable here, so z is nothing but that x bar, this is the normal variable, minus its expected value of x bar divided by square root of variance of x bar. If any variable any variable is subtracted by its mean and divided by the standard deviation, it is z standard value. So, what is this? X bar minus expected value of x bar is mu, we have already proved, and your variance is sigma square by root n. So, it is sigma square by variance is sigma square by n. So, this is the quantity, or other way I can say z is x bar minus mu by sigma by root n. So, this will follow z distribution. Now, here in t case, what is happening here? In this t case, you see that what we are saying, suppose the x bar minus mu is there, but sigma is not known, you are using s. In z case, x bar minus mu by sigma by root n, this sigma is population standard deviation, but this is not known, instead you are using sample standard deviation in the t case. So, s is a random variable, but here sigma is a constant. Now, depending on the situation, ultimately what will happen, there are different conditions. If sample size is very large, then the same this quantity can be in unit normal also, but most general case is this quantity is t. Why? Because this quantity follows t distribution. How can you justify that this quantity follows t distribution? If you want to justify this, then I just rewritten this one. The same thing I have rewritten in this manner, x bar minus mu divided by sigma square by n, and then the square within square root component is n minus 1 s square by sigma square 1 by n minus 1. Just manipulation. What is that? The numerator and denominator is manipulated with some constants. What is this x bar minus mu by sigma square by n? This is z, already we have seen. This is z, top portion. What is the bottom portion? Earlier I have shown you that n minus 1 s square by sigma square follow chi-square distribution. You go back, you will see. What is this? This one, chi-square distribution. So, your resultant variable is that z value, z random by the square root of chi-square by its degrees of freedom. So, it is t distribution, that is the use. Why you will use t distribution in this case? Okay. So, you see this formula and appreciate it, because if you understand this, huge problem will be solved. That is the use, follows chi-square distribution. So, the resultant quantity is this. Now, you require to use chi-square table. This is our chi-square table. So, please keep in mind, and in chi-square table also there will be degrees of freedom. Degrees of freedom coming into consideration because the parameter is degrees of freedom, the parameter of the distribution is degree of freedom. Okay. I think you will be able to find out, suppose if I say that my t distribution with 11 degrees of freedom, and what is the probability, that means that 0.0025 if we consider, then you will be getting a value of 2.228. But if you see the z distribution for the same thing 0.025, there is no need of any degrees of freedom, 1.96 will be the z value. Okay. Then come to f distribution.
Sir, one question.
Please.
Sir, in t distribution there is a what student is associated. Why that student?
No, that is developed by that Gosset, I think. I just yes, and it is developed while he was a student. So far, I know this one. Student, the T distribution is
So
there.
the basic difference is that instead of using the population variance, we are using the sampling.
Sample variance. But population variance is still there, that n minus 1 a square by sigma square. Okay. But question is that but when we compute the t, there is no population variance. When you compute t, there is no population variance, S is there.
Yeah.
That everything is can be calculated. So now I want to know what is the distribution of this, and we found out that the distribution is T distribution. Okay. F distribution. Now come to a ratio measure. What I am trying to, we will see here. Suppose you have two population for the same variable, population 1 and population 2 are characterized by the same variable, and you have computed, you have taken sample from both the population, you have computed your standard deviation or variance for population 1 as well as population 2. You want to compare whether variability in population 1 is different than the variability in population 2 or not, or they are basically equal. That means you are basically creating a variable which is suppose S1 square by S2 square. This is coming from population 1, this is coming from population 2. Whether two population are having same variance or not, in many models we assume that the population variance are equal. For example, when you do ANOVA, even in MANOVA case also, we will be seeing that one of the condition for sometimes we use that population variances are equal. That means this ratio we want to require to know. In ANOVA you will be finding out the use of this enormous use of F distribution. In regression also you will be seeing. So the ratio when your some quantity you are finding out, which is basically the ratio of two chi-square variable divided by their respective degrees of freedom. Then the quantity, basically this is what I mean to say, that if this is the W, this W, if we create like this, the quantity follows F distribution with 2 degrees of freedom, numerator degrees of freedom and denominator degrees of freedom. Why? You see the distribution here, nu 1 and nu 2, nu 1, nu 2, everywhere nu 1, nu 2 is there, rest are gamma function basically, other cases. So getting me? So this distribution is characterized by numerator degrees of freedom and denominator degrees of freedom. And when do you use F distribution? When you derive any quantity which is the ratio of two chi-square variables, and definitely that ratio, weighted ratio, ratio means weighted ratio of two chi-square variable, where weight is nothing but the degrees of freedom, 1 by that degrees of freedom. You are getting me? For example, what I say, let us see the use. Let us see the use. See S1 square, S2 square from two population, that population variance is sigma 1 square, sigma 2 square. I can write this like this because all of you, we have already seen that n minus 1 S1 square by n minus 1 S square by sigma square follows chi-square distribution. So that means this quantity will be chi-square divided by degrees of freedom. The denominator quantity will be again chi-square divided by the respective degrees of freedom, correct. So this is W and this one is F distributed. So in F distribution, please keep in mind, when we talk about F distribution, there will be numerator degrees of freedom, denominator degrees of freedom. So when you go to see the F distribution table, you have to see the two different degrees of freedom. For example, if you are interested to know for 5 numerator degrees of freedom and 3 degree denominator degrees of 3 denominator and 5 numerator degrees of freedom with a probability value 0.025, then you find out this value, you will be getting this value 0.7, that is 7.76. Okay. So, this way it will be used, and central limit theorem is the final one for us today. Again we will discuss next class, we will discuss the sampling strategy. Today we will finish by this. Central limit theorem says that if you sample from normal population or other population when the sample size is large, then the distribution of x bar, the statistical distribution, that is the sampling distribution of x bar will be normal. X bar is normally distributed with mean mu, variance sigma square by n. Okay. So, there are many sampling strategies. First one is random sampling, stratified sampling, cluster sampling, systematic sampling. There are some other sampling, convenience sampling, all those things. Basically, we talk about the sample statistic. That means you have collected data. How you have collected data? Strategy means what method you have adopted while collecting the sample. Random means you will randomize the collection procedure in such a manner that each and every observation is equally likely to come. Okay. Stratified sampling is sometimes required. What happens? Suppose you want to see that at different age groups what is the pattern, suppose for a particular, suppose blood pressure pattern, then you will create young people, middle people, old people, 3 strata you will create, and every strata you randomly select observation. Cluster sampling is what? Cluster sampling is, suppose you think that our exit poll this time for panchayat election in Bengal, there are in West Bengal there are so many districts, each district is a cluster. Suppose you cannot go for every district and collect sample from each district, you can randomize the cluster. So, that means you will select based on some randomization experiment, you will select some of the district. Suppose you select one district based on randomization and every voters on that district is sampled, then that is single stage cluster sampling. Now, it may so happen that you may go for 3, 4 or even more district at random, and again each of the district you will collect data from individual selecting randomly. Getting me? First one is district, number of district is there, you select one randomly one district, sample everybody, that is single stage cluster sampling. Second is first randomize the selection of the district, take few district, and again in each district you randomize the selection of individual, that is 2 stage clustering. Now, if you again in district level you can go for city also, there one more randomization is possible. So, that multi-stage clustering will come. Last one is systematic sampling. Systematic sampling means you basically follow an order. For example, suppose the 10th day you will set a target, for example, suppose the kth observation you will collect in one sample, correct. Suppose the population size is n, sample size is small n. So, that and you want to, suppose this quantity is k, you want to collect a sample of n. So, what you will do, from the first n observations you may be at the nth point you observe, then you go on adding k, the second observation will be after you will select the L plus kth item, then L plus 2k item, that way you will collect the n sample. Getting me? So, these are the strategies, and you go through some books and you know that, as I told you, that T distribution and F distribution will be heavily used, and F distribution, all of you know that R. A. Fisher, that English statistician, he has contributed a lot in agricultural sector, and George W. Snedeker, American mathematician, they are the pioneer in developing the F distribution. Okay. In next class, I will bring that student distribution, that particular person, because this will you can remember throughout, because you know Fisher and Snedeker, that they have basically developed the F distribution. Snedeker and Fisher. R. A. Fisher is a well known name.
Sir, reference was that
Montgomery and this Axel AD Complete Business Statistics. These both books are very much available. Okay. And for multivariate statistics, Johnson and Wichern and Hare et al. That I told you in the beginning, please. Okay. So, next class we will discuss estimation, particularly confidence interval. So, I think again it will be on Tuesday, coming Tuesday 7 o'clock evening, Tuesday 7 to 9. Okay. Okay, thank you very much.